compostable tech to Edge AI, Arduino experiments, different workshops. We're going to continue today with some amazing sessions as well, and workshops that will be held in parallel in the separate rooms. So make sure to be on time for the workshops and also to attend the keynote sessions and the different sessions. Unfortunately, you cannot clone yourself to be on both sides, so try to pick wisely. For today, again, I would like to thank the sponsors of the conference, under the patronage of the Prime Minister's office that SFK is being organized this year, and also the FLOSSK team that has done an amazing job to organize this event. So without losing much more time and bothering you with speeches, I'd like to invite to the stage the first keynote session for today, Joe, who's going to speak about the beauty of free software and the innovation behind free software. All right, cool. Floor is yours.
Thank you. Yeah. Hello, my name's Joe. Thank you very much for having me. As you can tell, I'm from the UK. Yeah, it's wonderful to be here again in Kosovo and in Pristina for SFK 25. Thanks to all the sponsors and everybody for putting this together. Amazing, and I'm really thankful to be here. I have a slightly sort of pretentious sounding title, you know, Outside the Locked Box, Why Open Source is Innovation. But don't worry, all it's going to be is me really quickly blasting through a load of slides where I show off about things that I've made, and there'll be about 3 useful points in the next 40 minutes. And I've handily just written those down so we can make sure we spot those. But yeah, I want to tell you a little bit about who I am and sort of my journey and why I'm here. So I'm a freelancer. I'm really lucky that I make things and I write about it. And I make things and I sell the story to various kind of clients and organizations. I've written a couple of books. So yesterday I ran a workshop on FreeCAD, which is a brilliant mechanical engineering package. And you can download this book for free from the Raspberry Pi Press, and it can help you learn FreeCAD. Today I'm running a workshop on KiCad, which is a brilliant free and open source bit of software that allows us to make industry standard printed circuit boards that we can get manufactured and build amazing open hardware projects. I also have, because I'm obsessed with like spreading the word about open source, I have my own magazine which I give away for free, which is called Source Magazine, and it's just full of tutorial content where you can learn about wonderful open source tools. Some of it is incredibly geeky, so the first issue is 12 pages on computational fluid dynamics setups in FreeCAD, but then the second one was about some stuff to do with game design and etc. So do take a look at those if you like free resources. And then when I'm not writing, I love going and talking to people, and I love kind of running workshops, and thank you. I was wondering if that would be a good idea. Even in my little rural place where I live in North Wales, I'll quite often go out and like run crazy workshops like, let's design a rocket with open source tools. And so this is a rainy Tuesday night up a mountain in Wales in the UK, and we managed to get 12 people aged between 10 years old and about 82 years old to design and simulate a rocket in flight using completely open source tools. So yeah, I'm a bit obsessed with rockets. So this is a rocket that I built. It's about this big. It's called the Open Development Rocket because it's open source. So I put the design of this rocket online. It can fly to about 3 or 5 or 6,000 feet. And I just do it kind of for fun. But other people have used this to do like air quality monitoring at specific altitudes and flying experimental electronics and stuff like that. So yeah, rockets will appear a lot through this talk, but don't worry, just let it wash over you. I quite like making things that fly, so I built things like this was an aeroplane that all the wings fold away, and it flies up under a rocket motor. it sort of explodes and turns into a plane like a transformer, and then hopefully flies down in circles to land nearby you. It quite often doesn't land nearby you, but that's another story. I make all kinds of things. I'm really obsessed with building watches, and I got a magazine to pay me to write articles about how to build watches. I'm really into sewing things. I really like sewing. I built a boat, and I look really grumpy. I don't know, why do I look, I built a boat and I just look really cross about it in the magazine article. I promise you I'm not cross about it. I really enjoyed it. I sometimes get involved in like, what in the UK there's a term activist engineering. And so this was an example of, in the UK we had lots of people using electronic cigarettes because tobacco cigarettes are very expensive in the UK now. And so there was all these e-cigarettes that were single use and they were getting thrown away as litter. But they contain amazing components like a little lithium polymer battery and you know, bits of circuitry and nichrome wire and all this like wonderful stuff that's just lying as waste in our streets. So a global electronics company called RS Electronics, who are like this like global megacorp, you know, they sell stuff all over the world. They hired me to build some, they were like, okay, we like what you're doing, build some crazy stuff using e-cigarettes. So we built like an MP3 player, we built a USB power bank, we even built, it may be hard to see, we built a laser cut drone that flies using a discarded e-cigarette cell. And most of this is open source, and most of it uses open source tools to make all the parts. So, you know, my laser cut components are probably made using Inkscape, which is a great open source tool for drawing. My 3D printed buttons are made in FreeCAD. Some of my circuitry will be made in KiCad. Other stuff, I do a lot of stuff in the air. I like to do things on the ground. So this is a commission for a magazine called Hackspace Magazine. And they wanted me to build like a modular robot that people could use a little bit like Legos, where they could change components and make changes. So this was really interesting for me because this is where I started to see some of the benefits of open hardware. I built this and I designed it all in FreeCAD so anybody could get the tool to sort of change the design. And I published all the design files, and it works really well, and people can kind of tinker with it. And then wonderful things start to happen, like colleges started getting in touch with me and saying, hey, can we use your robot to enter a robotics competition? And of course, they make changes to my design, but then they share their changes. So the whole sort of scenario gets better, where people start sharing their ideas and working together. And so now there are numerous teams using like the basis of my work, but there are loads of like, if you want to put a different component on it, there's probably somebody who's designed a mount for it, and it's super cool. Do lots of stuff with robots. This is a robot where the big yellow circuit board was a chapter in my KiCad book. So that's how the project started. I designed it as a chapter in a book, and then people sort of online, people started saying, well, that's cool, can I get one? And it was like, yeah, it's completely open source, so you can make your own version of it if you like, but it's quite complicated for people to maybe have one complicated circuit board made for them. So what I did was I took my complicated design files and sent them to a place where you can order lots of PCBs. So I ended up doing a first run of like 200 PCBs and selling them to people, but I kind of don't want to sell them the complete project. What I really want them to do is go on their own journey of learning, and I want them to make their own wheels, or I want them to make their own laser cut mount points on top. So yeah, and with that though, I get this real benefit that the thing that I have designed and I love suddenly gets expanded. So for example, this person went completely nuts and designed and built a really complicated power system to power this robot, which is like a huge project and many hours, but they've shared it online and the community can use it. But also people do quite simple things like this person just changed the way that the motors mount so that there could be an encoder on the back of the motor that cleared the PCB. And both of these are like really valid contributions to that project. And so I hope you begin to see how, like, working in an open way, you quite often get something that's bigger than the sum of its parts. So we've done rockets, we've done on the ground. A couple of months ago, I was asked to design a tiny open source underwater robot. I don't know where we're going next, like a journey to the center of the Earth, maybe, I don't know. So this is a really simple project. It's a little bit of 3D design in FreeCAD, some motors, some little canisters as flotation devices, and then there's a little bit of electronics that I did for the control system. And it's a really good sort of thing you can do in an engineering department to sort of engage students and play with control systems and stuff like that. But again, it's open source. So all this design is shared on the internet. And then sometimes really wonderful things happen. So I was at an event in the UK, and I met this organization who went into schools and did education with young people around robots and robotics and electronics. So I said, oh, here, and I gave them like 2 or 3 of these kits and said, here, have these, like, play with them. About 2 months later, I got a message online asking for my physical home address. And I was like, yeah, okay, here's my address. And a package arrived, and it was this. So this organization had worked with their young people. They'd used not just my KiCad book, but they taught themselves how to design circuit boards, and they built this entire control system and then wrote a firmware for my little underwater robot. And they open sourced it and published it online. The wonderful thing is that organization can use this for all kinds of things. They can build games for it. They can control other robotics projects in their project. But what a wonderful thing. Like, I didn't have time to build this, but because I'd maybe inspired another group to get involved, this other group came up with this whole custom system and went on that big odyssey of learning. So we're coming up to the first point that I might make. Watch out for it. But it happens on bigger projects. So this isn't a project of mine, but it's a project that I love and I've written stories about. So this is the OpenFlexure microscope, and it's a really cheap but incredibly capable microscope. So this gets used for like really high-end medical work and biomedical research and stuff. But it can also, it's cheap enough that it can go, it also gets used in areas where they can't afford to buy microscopes where the service engineer to come and replace one part is going to charge about 10,000 to get to their region. So this is a project that's gone all over the world. It has a Raspberry Pi computer in the base, and it has some really cheap stepper motors, and it uses a system of flexing to get sub-micron control of the platform, and it can do like really clever tiled imaging of your samples. And the wonderful thing is, it's completely open source, and you can 3D print this at home, and you can build this for like maybe $100 US, maybe a little bit more, maybe a little bit less. So of course, people start to do crazy things with it. A team from the University of Bath wanted to take it to the middle of a rainforest in Panama, and they were like, we want to work out how to make it compact and mobile. So they built a little design that held a display that folds away, and they open sourced that design so people have access to that. And then they also rewrote the firmware slightly so that it would run off an old Nintendo controller, because they're super rugged, and you can kind of find them all over the world. So it's been to rainforests, it's been to the Antarctic, looking for microorganisms in Arctic sea ice. So, and the brilliant thing about this is, as the project developers, they get so much information about how their product works, and people make all these changes, and the whole project gets much better, much, much quicker. So here's my first point. Whew. Having somebody build your project or your product is often way more valuable than having someone just use your project or product, in my opinion. So the golden circle is when somebody builds it and they use it. And that's a huge way that I think open source is really innovative. Okay, we're going to go into a different phase of stuff that I'm going to show off about now. Years ago, I became obsessed with tiny satellites that could go into space. And these are, this device here is 50 millimeters cubed. So they get called a pocket satellite because they can fit in your pocket. When I got involved with this, there were a concept that was coming out of Stanford University in the USA. And I was obsessed with this idea. I was like, whoa, that's cool. You can build a spaceship that goes in your pocket. Like, that's kind of radical. And I helped be, if you haven't noticed, I'm quite loud, and I quite like talking. So I became a person in the community who started talking about lots of these, even before they'd flown in space. And so I got involved in the first 4 teams who built these Pocket Cube satellites, and they eventually started going to space. And by now, we have about 200 of these. I also was helping people work out how to CNC machine different chassis and different components for these satellites, using like sort of hackerspace or home-level equipment that people may or may not have access to. Around this time, I got asked to do a TED Talk on this, and the TED Talk led this organization, or what became this organization, to reach out to me. And actually, when I came to Kosovo in 2019, I spoke quite a bit about the LibreSpace Foundation. The LibreSpace Foundation took part in a thing called the NASA Space Apps Challenge, which is like NASA set some questions for the community, and people all over the world can set up their own little hackathons, basically a party, usually in like a hackspace like the brilliant Pristina hackspace, and you all drink coffee, there's no beer, there may be beer, and we eat probably a lot of pizza, or maybe salads, because we're healthy. But no, and people work on these themes. The theme in 2013 was about satellite communication. And so the stuff that started that weekend became this project, which is called SatNogs. And what you're looking at here, inside this box, there's a Raspberry Pi. It could probably work these days with one of those snazzy Arduino Uno Qs I keep hearing about. But it's got a Raspberry Pi computer in it, and this is a quite technical one that it can move and it can rotate these antennas, and it can track satellites as they cross the sky. There was a much simpler version, which is this box with just like a static antenna, which works really, really well. It's connected with an Ethernet cable to the internet, but it also gets its power over the Ethernet cable as well. So, and then it connects to a website, and people could build these because it's open source and completely shared. You could build these again for maybe, at the time, maybe about $150, probably now maybe more like $200. And you could connect them to a network of ground stations. And you could schedule them to turn on and listen to freely available and accessible satellite data from spaceships in space. So this is where I live, and that's my ground station. I don't think I've given you enough information to turn up at my house there, so I think we're okay. But and so this is kind of what the website looks like. And so say FIEC built a small satellite and got it launched, which is totally doable. We've helped lots of universities around the world do this, yeah? I helped an organization in Nepal do this in 3 years, so their undergraduates in their 3-year degree built and launched a satellite, went up on a SpaceX Falcon 9 rocket, and went into orbit. Super cool project. But say FIEC built a satellite, you'd probably put one ground station on your roof. And what that would mean is, maybe once every 3 or 4 days, you would get like 40 seconds worth of data as your satellite went over. But it might be like 4 o'clock in the morning, and you might not have a system that allows a student to have a key and go on the roof and turn it on. Or it might be dark, of course, so your satellite might not be showing any good data about its solar cells or whatever. So if you join the network, interestingly, you can have access to the whole network of SatNogs. So this is a very old photograph, and there's lots more of these pins all over the world now. including one in Kosovo. This actually now represents one satellite in about 2014. So if you built that satellite and you joined this network, you would have each one of these is like your kind of 40 seconds or minutes coverage. And so you pretty much would have access to global coverage that could listen to your satellite. In 2014, this passed over a tipping point. For certain frequencies, our little organization that had put this open source project out there had more coverage than NASA or ESA, the European Space Agency, put together. That's pretty cool. We were quite proud of that. Not only were we proud, that meant we won a thing called the Hackaday Prize, and we won in 2015, and we won like about $200,000 US for this prize. So we thought, what should we do? Beer? Holiday? Maybe. No, let's do something more sensible. So we designed and built our own, what's called a 2-unit CubeSat satellite over the next year, and it's completely open source. You can go online, you can download every project file for every part of that spaceship, and then we got it commissioned to go to the International Space Station on an Atlas V rocket. In fact, on this Atlas V rocket. So that satellite is in that little Cygnus resupply mission next to the astronauts' clean underwear and, you know, their apples and their beer or whatever else they send up there. This rocket got delayed by like numerous months, which makes lots of the people in the project go, did I connect that thing? How are my batteries doing? Oh, I don't know. If you're a bit like me and you're thinking about stories all the time that you'd like to tell people, I spent that 3 months trawling social media to find out where the current astronauts at that time on the ISS were posting and pleading with them that when our little satellite got loaded into the Canadarm, which is like a big robotic arm that hangs off the end of the International Space Station, would they please go into the cupola, which is a big viewing window, and take some photographs. And they did. So what you're looking at, the second one, is our satellite that you've just seen going into low Earth orbit at about 430 kilometers above the Earth. It would pass around the Earth once every 90 minutes. It was traveling at about 21 to 22,000 miles per hour. And it was all built by people like me, but maybe a bit cleverer. Oh, that was no. Leave it just as one clap. I think that's great. Leave it. No, leave it. Perfect. One clap. Thank you. No. So, where it gets really interesting is when you launch anything into space and you're an organization, you kind of jump up a technical level. In the European Space Agency, they have a ranking scheme called TRLs, which is Technology Readiness Levels. And suddenly, we were getting invited to all kinds of conferences and to host all kinds of things. And what this has led to, what this has led to is, at this conference in 2017 at Darmstadt in Germany, which is one of the European Space Agency operational centers, there was a man in the audience who was really excited about our kind of dynamic maker open source culture. And he was like, you could do work for us and you could do it in a really fast, innovative way that we struggle with because we've got 10,000 employees spread out all over the world. So the LibreSpace Foundation now takes very big, like close to sort of €1 million contracts from the European Space Agency to do all kinds of work. Like, there's a thing at the moment called SIDLOC, which is a little device that will help us to track debris in orbits from missions. We did a project called SDR Studio, which did a load of work to do with software-defined radios. So as much as these things start as like groups of people in little hack spaces, they can grow into like big industries where people get paid to do all kinds of stuff. This is a weird segue. I just want to talk about rockets because, you know, it's been about 20 minutes since I mentioned rockets, and I have to keep mentioning rockets because I'm obsessed with them. I told you that I help people kind of build even like model rockets, which is a great learning activity, or up to kind of like stuff that might be classed as amateur, high power, or sort of research and experimental rocketry. In rocketry, we have a really old open source tool called OpenRocket, which allows me to symbolically design and simulate small rockets. What it's doing behind the scenes is a set of equations called the Enhanced Barrowman set, which are not that complicated for clever engineering students like you guys at all, but they're quite long-winded. And if you change one element of your design, you have to go through them all again, and you drink thousands of cups of coffee, and you get through a lot of paper, and your calculator runs out of batteries and stuff like that. What OpenRocket does is it speeds up the development of rockets. So it has an open database in it which contains all the commercially available model and amateur and research rocketry components that are sold all over the world. And that database is also open data, and that comes in a little bit. It allows us to simulate a rocket flight and look at this is coming down in 2 separate stages, and it shows us all that information. And this is a tool that allows us to, if we develop our own rocket propulsion and we test it on a load cell stand, we can trace the curves that are created, and we can create motor config files, and then we can test our designs as many times as we like with our proposed motor. And that aspect of it leads to things like this. This is a project from the US called Mojave Sphinx by Half Cat Rocketry, and this is serious stuff, you know. This will go up about 20 to 25 kilometers, and it will perform all kinds of like research functions. The interesting thing about this is it has a bi-propellant liquid rocket engine, which is exactly the same technologies like the big SpaceX type rockets and things use, and it's never really been built at this scale before. This is a wonderful project that's really well documented. If you want to read a really well documented, open source, whole design shared project, this is a really good one to start with. But the important thing to know is that as much as I use those previous tools for my little model stuff, they use those tools for this kind of stuff. But there's one thing that that other tool I was just looking at can't do. I can't take this design and get like a 3D printable output or a machining output where I can cut the fins out on one of my machines. I can't get that kind of CAD output from it. And so a while ago, I realized, FreeCAD probably could do this. Somebody cleverer than me could probably make a workbench that we can add on to FreeCAD that could help design rockets. But I'm not clever enough to do that. I'm not a developer, really, so I don't know that software stuff. So I wanted to share this story just about how the mechanics of open source culture sometimes take place. So the worst thing you could do is like walk into the FreeCAD forum and go, hey, somebody make me a tool. Because people will just go, well, they'll swear at you probably and tell you to, go away, they'll say. So what I did was I jumped on the FreeCAD forum, and the first thing that came out of my fingertips was, you say thank you to that project. First of all, massive thanks to the developers in the community for such an amazing project. FreeCAD rocks. I'm proud to use it. Say those things, say those things and give them that value that they deserve for developing this tool. And then I went on, I got into CAD because I like designing rockets and blah, 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 and there's this project I use, and it'd be really cool if I could take my data from OpenRocket, the simulation thing, and if I plugged it into FreeCAD, it could like create the geometry in there and rebuild that project. I don't know if that's possible. So a couple of people started talking about it, and then there was a guy in Canada who's also into making model rockets, but is a developer, and I thought, ha-ha, here we go. But he didn't know how to build it. He was like, I'm not sure in FreeCAD how you would do this bit of it. Like, I'm not sure how the concept of like parts plugging into each other would work. And then, of course, like, you get other wonderful people in our community, like Suzanne said, oh, okay, to solve that bit, you'd use sub-items, you could use the app property link properties and all this stuff that I don't understand. But within moments, we're up to, like, 15 pages of discussion, and suddenly it all seems a little bit more like we can do this. So, within about 3 months, this is the first Rocket Workbench. You can see it here, the Rocket Workbench that's been plugged into FreeCAD, and I can take the data from that other program and I can chuck it into here. That's amazing, and it's free. But not only that, it has that open database of components in it that the other bit of software has because it's open data. So I can rebuild a project in here without even using the other bit of software. Or I can input stuff parametrically. And this sort of data input in FreeCAD in the Rocket Workbench looks exactly the same as it does in the other bit of software. And that can only happen because it's open source. Because if you did that with a proprietary tool, they'd sue you for stealing their branding and their interface design. And so it's been wonderful because I can now take CAD and FreeCAD and I can make it interesting to the rocketry community. So the rocketry community are starting to use it more and more and design more complex stuff. But a little bit like LibreSpace, it goes beyond that and it starts to butt into industry. So in the test branches, we're working on this. So this is a fin flutter analysis of a rocket fin as it transitions through the speed of sound. There are about 12 academic papers in the world about fin flutter analysis. Most of them have come out of NASA, and it's a really complex, emergent part of the rocket industry and academia. What it means is, when your rocket goes through the speed of sound, the fins get shaken a lot and they flutter. And what we tend to do is make them way too strong so that they survive. That's what we do, but of course that adds weight and it adds drag and it de-optimizes our rocket. And if we can make it closer to optimal, that is like valuable in terms of like millions and millions of dollars. If you went to a proprietary CAD company, I won't name them, but we all know like some of the big CAD companies in the world, they would probably charge you about $20 to $30 million to develop that tool right there. And then they would want to rent it to you for about maybe $1,000 to $1,500 per analysis. That's kind of how that market works. So we have it for free. You could just, anybody in this room can download and install that. Anybody. My 14-year-old son performs fin flutter analysis on model rockets in our garage, you know? Like, this is something that's incredibly accessible that would cost millions of dollars. I think that's really innovative. It also led me to get obsessed with computational fluid dynamics. And oh, I forgot to tell you, like, I'm not an engineer. I'm a youth worker. Like, that's my kind of background. So none of my stuff is like engineering. So in my first Source magazine, I went through a massive journey of self-learning over about 3 months and taught myself how to set FreeCAD up to do computational fluid dynamics analysis of objects like weird parachutes or whatever, and publish this information out there so other people can follow along that journey. The interesting thing about it is that I came up against my limits here. There were things that I really did not know and I needed specialist help on. But it's quite interesting what sometimes happens there. So a university in the UK that I won't name offered to help me and said, we've got some CFD people in this department, I'll put you in touch, here's their email. And most of them were really knowledgeable and they came back to me with really good information. But I want to show you one little email. So there was one guy, and I sent this email out, and you don't really need to understand what it is, but so I'm getting asked to input a relative pressure reference when I set up a computational domain like this, and I don't really know the physics, like the inlet and the outlet are like, the flow is incompressible. Am I correct that the density value doesn't really matter? So, you know, it's a really sort of technical question that I don't know because I'm not a fluid dynamics expert. And one of the responses I got was this. Hi, Joe. I've not had to do this personally. I got a pretty good answer, though, inputting your question to ChatGPT, but I'll leave that up to you. So this was fascinating to me. Like, I love that he's put it into ChatGPT and he might get a decent answer. That's amazing. But I was like, okay, this guy's a CFD person. Like, he sits in a material sciences department doing computational fluid dynamics. But he doesn't quite seem to know, like, some of the underlying physics. And what happens is, say you use, like, SolidWorks, and your university gives you an academic license for SolidWorks, which is a big, brilliant proprietary package used widely around the world. You don't really do computational fluid dynamics with SolidWorks. You rent the opportunity for somebody else to do your computational fluid dynamics for you. So a student in the UK, they might get really good at designing a model in SolidWorks, and they might get really good at defining a problem in SolidWorks, but then they would send those two things to the cloud, and SolidWorks would plug it into the ANSYS system and run their computational fluid dynamics analysis, and they would send a report back. And that's kind of a different thing than knowing computational fluid dynamics. So I'm coming to my second point you'll be pleased to hear. Open source promotes learning. And learning is quite often better than service using, but it also leads us to better service use. So sometimes open source allows us to get into the nuts and bolts of things and really understand them at a level that then when we use a service like SolidWorks to do this analysis, out of interest, that costs about $800 per go. So if you've got something wrong in your model, your academic team are very cross with you. If you understand the fundamentals of things, you're probably going to be better when you use services. I'm nearly at the end. I wanted to show you one more example of open source innovation. This is a little thing that I built. It's called FilaWinder, which is a very silly name. What it is it's a desktop carbon fiber filament winding machine. So you can make carbon fiber tubes in your bedroom. I mean, you know, who doesn't want to make carbon fiber tubes in their bedroom? You can put a little vat of resin in the path of the carbon fiber, and it will wet, and it can apply, and this all moves, and it all travels about. And it uses a really affordable Arduino system and some open source motor drivers called the GRBL CNC system. So you could build this for, like, I don't know, $80 maybe, and you could, if you wanted to have that technology. It's all 3D printed, it's all designed in FreeCAD, and the reason I'm showing you that is because of the story that inspired it was this guy. I haven't got a very good picture of this. This is somebody who's now a good friend of mine. This is Julian, and he turned up to an event a bit like this in Brussels, and he was talking about FreeCAD and how he'd used FreeCAD in a thing in the UK which receives millions and millions of pounds called the Advanced Manufacturing Research Centre. It's attached to a really good engineering university, and it receives like significant sums of money for the UK government to do innovation. What they wanted to do there was they wanted to filament wind, but they wanted to do like complex structures, not just tubes, things that curve and bend and have corners. Sorry, these are terrible quality photographs. What you're looking at, this is like a 6-axis industrial robot, and this is like a CNC lathe, and so it has all different ways that it can articulate, and it can fold the filament around the form. And so what they wanted to do was do experiments about, how do we fold the filament back on itself, and how do we do this in a way that is really, really interesting. And what they couldn't do, though, was they couldn't get any CAM package to run this machine. Because again, if they wanted, for example, Autodesk to build a CAM package so they could visualize in the software the flow of the filament and all that kind of stuff, what Autodesk would want them to do is send them this entire laboratory to their facility in the UK. So you would send this entire setup to them, and then they would charge you an awful lot of money and take a couple of years to build your tool for you, and then they would rent that tool to you. So you wouldn't own the tool, they would rent that tool back to you, and they'd send you your machine back and then rent you the tool to like do the CAM. And And that's really common. I'm not demonising course, that's like a really common way that that industry works. And so what was happening was, like, one academic could write a really complex bit of scripting for like one go, and it wasn't satisfactory. So Julian said, we could build this in FreeCAD. Like, FreeCAD is completely open. You can see every line of code in FreeCAD, and it's all Python or C. And it's all open. So he set about building this open source little workbench add-on, which now I can use with my tiny little desktop setup in my bedroom back in Wales. It's not in my bedroom, it's in my shed. My partner wouldn't allow it in the bedroom. That's where we keep the 3D printers. You know, I have access to this amazing bit of technology. And who was this technology for? Oh, it was a project for the Advanced Manufacturing Research Centre with Boeing. So this is like Boeing are now at a point where they realise the closed systems don't actually meet their needs. And so in Boeing's Advanced Manufacturing Research Centre laboratory, it's FreeCAD which is running the CAM for these machines. And that leads me to my last point you'll be pleased to hear. And it's a common saying in open culture. If you can't open it, you don't own it. And that it applies to like my mobile phones, it applies to my vapes, not that I smoke. You know, if you can't open it, you don't own it. And so if your CAD or your tools for systems don't let you get under the hood and make cool stuff with it, you probably don't own it. And it's probably a lot less innovative. So there kind of ends my talk, apart from, I wanted to just show we're here. And funnily enough, globally, this month is Open Source Hardware Month, which is October every year. So I just wanted to give a shout out to the work that the Open Source Hardware OSHWA organisation do. And they're an organisation that they certify projects and check that when a project says that it's open source, it truly is open source. And so for me, if I see a bit of open source technology and it has an OSHWA certification mark, I know that it's like, I know that I'm going to be able to kind of use it, and I'm going to be able to maybe modify it. And then just as a final little picture, because you haven't seen a rocket in about 3 minutes, and that won't do. This is the first open source certified rocket in the world, certified by OSHWA, and it's one of my model rocket designs. And I'd just like you to know, if you haven't realised that I'm completely mad, this really tells you, because I spent all these years nurturing people to build me these custom tools to help me make rockets and broaden the community. And then I built a rocket that was hexagonal, and none of the tools worked for it at all because they didn't think anybody would build a hexagonal rocket. So even when I get what I want and I make the world a wonderful open and cultured place in hardware, I still have to be awkward and make difficulties. And yeah, thank you very much for your time. Get in touch. Please.
Hello.
It's on.
So, the first question was coming from this side.
Oh, no.
Hi, I think I know it. How do we build this garage experimentation culture in Kosovo based on what you know so far?
I think there's some really practical things I've seen this time here. And I think so I did a couple of lectures. I did a lecture here to some students, and I did a lecture at UBT, I think I'm saying that incorrectly. And both of them got excited by the rockets. And like, people think, well, that's really difficult. I don't know how we do that here. I don't know what the rules are. I don't know what the structures are. I don't know how the government would react. I don't know how the policymakers would react. But you just have to ask the questions in a sensible way. What do we need to do to launch a model rocket in a safe way that's like acceptable in Kosovo? And once we start those conversations, it's quite easy to move towards that process. So I think having conversations about things that seem difficult is one thing. But my other thing is lean more into the global open source hardware community. You know, I was massively motivated to help a guy set up Nepal's first domestically built satellite that went into space in 2022, and the program started in 2018. And all it took was me being vocal and another guy being sensible and like setting things up, and me saying, there's people being really sensible over there, and what they need is they need some money, and they need this technical stuff, and they need this, and like, you know, all kinds of agencies in their own country supported them, but all kinds of people around the world supported them. The open satellite community massively supported them. So I think, like, and it's not a charitable thing, like, open culture wants more open culture, like, we're hungry for it. So, yeah, get the other people in the world who are on your side to support you. And then, keep Pristina Hackerspace open. Keep inviting your young people so that it's not all full of old beardy weirdos like me, you know? And, you know, like, get your young people in there. See if you can inspire them to build something crazy that might not be rockets or submarines or robots. It might be medical devices, it might be drones, it might be UAVs, you know. Get them there, bribe them with pizza, make them talk. Good question.
Okay, there's another question here.
Thank you for the presentation.
Now this is going to be a question.
Yeah. No, I'll skip this morning's conversation. But thank you, and I hope the students really appreciate this, because it's very hard to get people excited and on board about stuff, especially to beat apathy that is usually in society. So I hope all the billion rockets that we're seeing there, they're like, yeah, at least one. But my question is more related to data. So you said that some of the data that were collected were then accumulated in some repository open source. So how can we access the data that was collected open source, and in which repos you might have, you know, like...
Is the question, how do we access the...
Yeah, you said at some point, amid the rockets, there were data. And you said that the data that were collected, to my understanding, if I was not confused by the images, to my understanding, some of the data were actually open source, right? Yeah, so did you pack them up in some repository, and how can we access them, and what sort of data do you have?
So I think the thing we're picking up on is, like I said, there was an open database of industry components built into one of the projects. So that's just a case of, it's linked to the Open Rocket repository, and then there's a sub-repository which is the industrial data. It's probably a big spreadsheet. So it's all kind of there. I mean, that's the thing with open hardware, is that most of the tools for sharing projects are actually built for open source software. So sometimes it can be a little bit tricky. But all the any kind of data that's either generated from projects, if they are open culture, it will probably end up on, you know, GitHub, GitLab, Codebug, Bitbucket. And so it's just a case of picking out the keywords of the projects that may have data that you want. Good. Oh, sorry, I didn't use the microphone. Sorry. I've got a bit of now. So.
Thank you for your presentation.
You're very welcome.
And congratulations on all of your projects. As much as it's inspiring, it is a bit overwhelming for someone like myself.
It's good. Let it wash over you over the next week, and you'll wake up in 10 days' time and think, I want to build a submarine. I don't know why.
Yeah, well, seeing all of this, I couldn't stop thinking on the hardest part on becoming jack of all trades is starting. So that's my question. What do you suggest? Where should a student like myself start?
I love that question. That's a great question. So in product design, you have this concept of the minimal viable product, yeah? Like, so almost everything you have seen, including things that have gone through all the validation and have gone to space, have started as either a sketch on a napkin or made out of waste cardboard. And I love the idea of the minimal viable prototype. So if you want to build anything, I absolutely suggest you just grab some cardboard and make a model of it. And it won't solve a thousandth of the complexity of whatever it is you want to build, but you'll learn something that's a step towards that level of a complex project being completed. So honestly, build something is all I can say. Build something and then iterate on it. And I might iterate on something for 6 months and think, this is rubbish, and I might start again. But I don't know that unless I build something. So just start. You know that thing where, I don't know if you have it in Kosovo, where people skip, and but you do it with two friends, and you stand at the side, and you have to get up to speed. And it's like, and then suddenly you get in there, and you're like, yeah. And it's that feeling, like, get ready, jump in, start. Good question.
Okay, I think there's one more question. And there's always the possibility to go to Pristina Hackerspace. They have lots of stuff to build prototypes and experiments.
Yes, do that.
Thanks for the presentation. It was very inspiring. My question is very simple. Where can we find the Source magazine? I was kind of looking it up and it was a bit hard. Okay. Oh, thanks. Okay, thank you.
Right, any more questions? I have another question for you. Why should the University of Pristina build a tiny satellite? Just because?
Why shouldn't they? It's an absolutely astonishing engineering achievement. I have this line that I say that's a joke, but also incredibly true. If you can get a tiny piece of metal validated to be put into low Earth orbit, you absolutely have my respect. Because the complexity of building a satellite is not particularly building a satellite. It's about the qualification checks. It's about liaising with international systems that coordinate frequency allocations for your radio communications and stuff like that. And it's all completely doable, but there's a lot of it and it's hard. But the outcomes for learning and the outcomes for inspiration are why I think almost everything that goes into space should be built in universities rather than in industry. That's not a popular opinion. But because imagine doing like an undergraduate degree and starting in your first year, and by the third year you have hardware in space. Like, that is an achievable thing for universities. And I think what that breeds is like, you know, and people might come out of that hating space and think, I'm really concerned about orbital debris, and I don't want to put stuff in space, and there might be all kinds of like things that brings up. But those people, those engineers and those makers and those creators will go out into the world thinking, I can build anything. We can build whatever we need. And so that's why I think people should build spaceships.
So let's say technically, University of Pristina would build something together with the students. Would there be a way to collaborate what you do to send a satellite on a rocket ship from EAS or NASA then to space?
Yeah, so that's the other reason we should do it, is that if you're not doing it for profit, so if it's a purely academic exercise or it's a purely amateur exercise, I can get you, I could, but lots of people could broker you like $10,000 per kilogram off the ISS into low Earth orbit. So like, you know, I haven't got $10,000 on me, but like, it's not an unachievable sum of money for even quite a small sort of department to raise. There's a lot of other costs as well. If you want to do it commercially and you want to put a component on it and test it in space, and it wants to be a commercial research venture, it's a lot more expensive. But if you're strict about making it, an academic learning project, it can be incredibly affordable. The cost is not the issue; the complexity is the issue.
Perfect. All right. Final question here, and then we'll wrap
Thank
it
you
up.
very much again. Oh, no, sorry.
So basically, I have a quick question. How will the open data from satellites such as like Starlink and like other orbit stuff
So it's a complex question with lots of ways I could answer. There's a huge amount of work for software engineers in building satellite hardware. There's wonderful sort of things to be done with, any sort of data that you're receiving might be useful for your scientific departments. Like the one that we built with LibreSpace had a sensor on it that was detecting a particular type of radiation in space, and there were 8 other satellites built by 8 other organisations flying the same sensor, and so we did like a coordinated data research project with that, and that helps pay for the flight. But yeah, I think there's lots of opportunities for software developers in satellite stuff. Building interfaces and dashboards for received telemetry and data and stuff like that. It's almost endless. So it would absolutely include your computer scientists. It would absolutely include your software developers and stuff. And I think you asked maybe a question about data. So there's a lot of public data coming back from space, and there's lots of examples I can give. The one that comes to mind is like anybody, you don't have to be an academic, anybody can log on to the European Space Agency Copernicus portal. It's a little bit complicated, but you can use all the geospatial data for anything you want at all from all the multi-billion-dollar technology coming from space. It's completely open. So people, of course, build entire companies around that, monitoring flooding or, the migration of, particulates in the atmosphere or whatever it might be. So there's an awful lot of open data coming back from space. So lots of opportunities there.
All right, thank you very much, Joe. Big applause. Thank you. That was an inspiring finals of Sunday. Lots of things to learn. Always excited to see people build stuff with hardware, which is hard, much harder than software. But of course, make sure to check out the resources that Joe shared, and also reach out to Christina Hackerspace to help you get started with your project and experiment. Always remember there's products like Arduino to experiment, to build stuff, to prototype, and CNC printers and 3D printers and so on. So now we move on to the next session. A long friend of mine who I know for many, many years, when I come up to the stage. I always know him for knowing and talking about technologies when they are very rare in the industry. He was learning Ruby when it was not being taught too much, and now he's onto something with Go, programming language. And please welcome to the stage Dr. Mizwani, who's going to talk about an open source framework called BASE, and we're going to be excited to see what's he doing, what's he running there, and how we can make use of it to make faster and more scalable APIs for your projects. So big applause for Dr. Come on, more lively, more energized.
Hello. Mine is not rocket science, so it's not that good stuff. BASE is backend framework written in Go, but before I talk about BASE, let me tell you why I built BASE. 2 years ago, I hired a developer to build a Rails application for a client, and at some point he said, let me start it in Go because I can move faster in Go. And of course I let it in, then at 95% of the project, he quit the job, and I didn't know where to go. So I had to move to where to go so I can finish the last 5% of the project. And I was amazed by Go because of that simplicity of Go that provides. And I never did something that compiles before Go. All other languages were interpreted languages that you put the whole source on server, but in Go, you compile it to one small executable file and run it on server, which is pretty easy. Now, why I did Go? Base. Because when I started to work on Go, I was looking for a framework like Ruby has Rails or PHP has Laravel, which are more familiar framework. And there is no such a full-featured framework in Go, which was kind of strange because Go is a new language, but it's very popular lately. All you get some HTTP routers, and it's easy. Even Go built-in has routers, so you don't need a different package. And then I started to take some bits and pieces of different packages on Go and started to make what I know in other languages that work. So basically I didn't invent anything on this framework. I just copied what worked on other frameworks. So Rails, it's like 20 years, was started 20 years ago by DHH, and today it's like so many big companies using Rails, including GitHub, Airbnb, Shopify. They are all built on Rails. So why try to invent something that already works when you have a proof of concept? So basically that's what I did. With all that experience in PHP and Rails, I just translated that in Go, and it should be very familiar for developers that don't know Go as language, but they know those frameworks. Yes, it's opinionated, but they are not my opinions. They are opinions of industry that they decided that this works, and you don't have to think how to name files, how to name folders. We did that for you. So you just put the files in those folders, and they work. So it's not MVC because we don't have views. We are building APIs, but we switched the V for S because we added services. So basically, you have three things. You have the model that lets you model the database. You have a service layer, which all data related. It's either called external APIs or database. You put it on service, and of course there is a controller which all HTTP requests and response are handled in controller. And they are all in hierarchical order. Yeah. So I split it base in two main folders. There is a core and app. On core there are built-in features that you use when you build things in app. So core is mine, app is yours. It's like we are doing the thing together. And I build the core features, you build the app focused features. And thank you. No, because Go has Go modules, we don't confuse with the Go modules, core modules. This suggestion came from Reddit because everybody was saying these are not modules, Go modules are different things. And when you create a base module, it's called base structure. It's structures because on base you build structures, and that's how we came out with the name structures. So, what does Core have? Core has a built-in HTTP router and middleware, of course. It has a database which supports SQL-related databases. It has an event system which you can emit broadcast signals inside the web. I will show it later. It has storage, it has email, it has everything that you need to build a backend system, powerful backend system. But application layer is where you build the core logic of your app. You don't change code, you just extend it in application layer. And all those structures can be generated from CLI. You can do anything you want, but in app, not in code. Sometimes you need more files, sometimes you need just a router. Everything you can do it in app. This is the CLI that I built. It has like 8 commands, but they are so powerful. When you do, when you do, this is a simple block tutorial. All you need is base new block. You CD inside the block, then you start generating code. For example, you generate categories, generate tags, pause commands, then you set the base start -D is if you want to generate Swagger documentation for those. And that's it. For example, when you generate new application, you ls inside that application, you get this structure. We have to flip it because it's too large. Like you get a lot of pre-made data that pre-made function methods that are tested already. This is production already because we built so many apps that are already in production, and the beauty is that you can set this on $5 VPS and it can handle 1 million requests. And that's the power of Go, not the power of framework. Frameworks just are tools that make this ready. Now, let's focus on generation. We have this command will give let you decide what type of fields do you want to have in database. And as you can see, you have relation that you can say author belongs to user and featured image is just a variable. With this command, you will have the power of not doing boilerplate code. It will generate it for you. You will get upload file management with one command. When you run this command, you get this in terminal, which will tell you that has been generated. These are the field types that you can possibly use. So you can specifically do a lot of types, and all of them have different does different things in database. mostly does validation. For example, when you say translation field, it will do a translation. That field will become a translation field, which is so easy to translate it in different languages. I will show it as a model scheme. So if you run this copy paste, it's already on the website. You can just copy it and paste in terminal. You will get automatically the whole blog system up and running in like 2 seconds. And if you mess up, you can always destroy those. For example, when you forgot or misspelled a method, you just destroy it with one simple command. Because when you generate, it generates so many files and touches so many other files, updates too many things. And if you want to delete manually, you have to go and find those places. But base destroy does exactly that. It reverts what base generate does. I was more happy when I did base destroy than base generate. So what makes core code? Core is made from some small complex packages which, when you use them in app, it will simplify your life. For example, the storage package supports multi-provider, like you can upload locally on S3, AWS S3, Cloudflare, and all you need is to say storage attachment is the type of field. And when you want, I wanted to do it so easy. For example, I just want to say storage upload and storage delete. The rest is handled by the storage package. And this is the emitter which you emit events inside the framework. When you, for example, when you create a user, you just emit user created and you pass that user that has been created. Then anywhere inside the app, you can just say unuser created, you get this data and you can do anything with that user object. So you don't have to, for example, when you want to add here when I create user, create another, for example, create new organization for that user. You don't have to do it inside the user method. You just, an organization, you can just say, when user is created, create this thing too. So you don't need to do things on core or anything else. You just, it's broadcast system, so you can easily use it. Same with email. I want it to be, as you can see, you have providers. You just set, for example, provider as SendGrid. You put the SendGrid API, and you can just say email message, write those, then email send this message. It's simple as that. Like with those lines of code, you can send emails from any place inside the app, whenever you need it. Or you can even do, for example, when user created, here you can use like unuser created, send email, welcome email to that user. And the authorization is a big part of platform. You can do a route check. For example, in this route, check if this user can create post or can list post. Or if there is, for example, like Google Drive, when you want to share a file with a user, you can just check here on the route if this user can access that file or to update or to delete. If that user doesn't have those permissions, then it won't pass. Or you can just directly say on /admin, only user with role admin can go. Everything else is. Also, we have a task scheduler. which basically manages cron job tasks. It doesn't do anything special, but it has so much flexibility, so you can control it even from your React app. The whole thing. You can add new tasks, delete, see what's running, and this is the code that you need. And here you write just what do you want to run when this task is ready to start. This is the translation module that all you need is to say title is translation field. In here you just call the translation helper in low translation for item. In this case, for title, for cost, models cost. Then it will respond title, it will give you the original that was on database for that table. Then it will give you the translation as a field translation, not the whole translation. Normally before this, we used to do, when we made multi-language websites, we duplicated the whole table in English and we started to translate in Albanian. Right now you can have field translation because you don't have to translate dates and images and things, but even if you want, you just say translation field and it will give you this. And I forgot a slide. We even have an MCP server for Base, which you can easily install it. When you go to base.al, you see how to install it. And I tested it, and it's so good. You see like cloud code generating, like if it's amazing how it works, how easy, because normally AI agents hallucinate and start add features. This MCP server tells exactly how Base works and generates things directly. And I tried to test it, and I said I want to build an e-commerce website, and it generated like 30 columns to run on Base. It ran those, and I had APIs for full e-commerce website like in 10 seconds. So that's the power of Base. Thank you.
Questions from anyone? There's one. Of course, there's always one.
Dr. I'm really interested to know about the MCP server that you just mentioned. Like, what is the structure of it? Like, it's hard to hear. Okay. Flegram, I wanted to ask you about the MCP server that you built for Base. Can you give us more details about that? I'm really curious to know.
About the what?
MCP server that you built for Base.
MCP?
Yes.
Do you want to?
Just in general, like what is the structure
in general,
of
MCP, what it does?
No, the structure of the MCP server that you built.
I don't have it here, but in general, what MCP does, we have the documentation on base.al/docs, and it takes those documentation and does search of those documentation. It gives you, because documentations all have examples, like copy-paste examples, and they work. So basically, it does that thing, and then AI, LLM, takes that information and makes it how, for your case, how it should work. So basically, MCP gives like documentation, gives you a blueprint, then LLM takes that blueprint and converts it to your case. So that's how MCP works in Base. And even I explained, there is a documentation document that explains how CLI Commons works. So he knows what those field types, he knows which field type to use for different fields. For example, if you say, I want to build a block, it will build you a block. But if you say, I want to build a block in multi-language, then it will use those translation models to make the title and description in multi-language. So I can give you a demo. Yeah, and everybody who's interested, I can show you during the coffee break.
Good, that's exciting. Like that, always more helpful.
Yeah.
Any more questions?
Let me see if I can. So, because of that minus D, it generated swag, and here it is. So now, slash docs. Wise. You get the Swagger with the core APIs directly. Then, when we stop the server, there is not new, but generate post, title, that app post has been generated and it has only content and title, because that's what we said. And it has a lot of background things that happen. For example, right now, if we try to list post, it said API key is not valid. You have to define some things in the environment file, because it's very secure proof. And we have this when we set API keys. I think it's change made. Let me go to work. Oh, yes. And yeah, this is the structure of the app. So in here it has only, this is the controller. Let me just see how it's changed in production. Let's create the post. kinds of field types, he changes things. Like it will return you the translation, or if this image, it will return you the image object, or it's just the URL of that image. And let me go to Basil, since we haven't done that. Good. Documentation, tutorial. For example, this is more bigger example. Okay. Yeah, it didn't find category tag and all those, so we have to copy paste. So basically, that's what it does. When you do a relationship, let me find it in here. Do we have time? Good enough, because we are doing in base. Cool. Now we have so now we have categories, we have comments, and let me create a category quickly. Okay, and let me create another post. But we will save category one, and author ID is one, and that's first update, publish. So as you can see, when you use the categories, it gives you category object directly with name and ID. So on that post, you can see exactly in what category, but not just ID, but it will give you the response of categories. So, for example, when you need to do the opposite, you can have post titles on that category, so you can list it easily. Then it's same, and that's all because we said post has many categories on this. Category belongs to category, because on post we said the post belongs to categories, and it automatically found that this post has to be in any category, or it belongs to this author, which is a user that can log in. And of course, the authentication, authorization, media, and OAuth, all are supported automatically by the code, so you can just configure them mostly in an environment file. And this is how environment file looks like. You have just to set, for example, you can do middleware configuration, and you can say, don't check those for API keys, those endpoints. Sometimes you need endpoints that should be open because they are like webhooks that someone else, some other servers should post to this endpoints. And here is how you, for example, configure MySQL or Postgres. You just set them, you change this to SQLite, from SQLite to MySQL or other databases. Same with email, you just say, I want to use SendGrid, then you put SendGrid API keys, and tomorrow you change your mind to use Postmark, you just put the key, nothing changes in code. You don't need to do anything in code. Same with uploads, for example, while working on development, you use it as a local and it will upload here in storage uploads. Then when you go to production, you just say, I want to use AWS, you put the API's keys, and it will upload directly to S3 or R2, Cloudflare R2. Those are free servers. And this is it. This is basic.
Thank you, Zaki. What we're seeing is demoed in front of the audience. So thank you very much for the presentation and for demonstrating and contributing with the base. So now